So what I do is I do incentivize improvement, so if you improve over time, then the grade gets a little better over time, even better than your report card would actually say it is. But I don't really like just, let me give everybody 10 points, it's not really my thing. So we want you to focus on you and not necessarily how everyone else is doing. You need to learn, okay, do I know this? That's the important thing. Not how bad am I compared to everyone else? It's not how you want to really judge yourself. So let's actually, looks good. Let's actually just jump into this, see what we picked up from last time. We had this guy. I want to find the partial fractions of that. What is the first step? Yeah.
Break it up into factor the denominator.
So the first step is to check that it's a proper fraction, right? Which means the polynomial on top is of degree lower than the polynomial on bottom. That one actually checks out. So the next thing you do is you factor the denominator. Does this factor? X minus 3, x minus 2. What do you do after that? Yeah?
You break it up into, first you do the denominator, so it's x minus 3 plus x minus 2, and then
What goes on top?
top would be the one degree less than what's on the bottom, so it would just be a and b, and then
And how do you find A and B?
you find a and b by multiplying the denominator out by multiply the denominator of the whole equation. So
Okay.
you get
Then?
so for this one I chose the first method, which was choose an easy x value, so you can make x equals 3, x equals 3.
X equals 3, that would give us A. Right, because the B would go away.
And then for the second one I chose x equals 2, and then I got b was equal to -1. From there I just plugged everything back
So
in.
this means that our original fraction, x squared minus 5x plus 6, can be written as 1 over x minus 3 minus 1 over x minus 2. Now that, I think, was the same example that we had last time, just running through it a lot quicker. That's what it would look like computation-wise. I want to show you a trick. It comes from a theorem called the residue theorem. So it's one specific instance of applying this theorem. This theorem is something you learn about in complex analysis if you ever actually take that course. So it's like 2 semesters away. So I'm not going to tell you the full theorem, I'm not going to tell you what it means, how to apply it, because it's above our pay grade at this point. But what this theorem gives us is the fact that we can actually, as a consequence of this theorem, find partial fractions in the coefficients in partial fractions in a certain case a lot easier. So the idea is the following. If you have linear, meaning the factors look like mx plus b, non-repeating, factors only, then there is a way that you can get to the a and b that is actually a lot quicker than either one of the methods that I gave you. But the trick I'm going to give you only works in this case. Once there's a quadratic factor, it doesn't work here. It does work, but it's a little more complicated to apply the theorem to those situations. In the situations of linear non-repeating factors, for example, which is what you have here, there's a short trick that you can actually do. One is for each factor. Some people call it the cover-up method. Find what value of x makes it 0, then in the original, cover up this factor, right? So essentially you want to actually ignore this factor, right? I.e. ignore the factor, right? And plug in the above value. The result is the arbitrary constant. It's crazy how that works out, but it actually works out very nice. So, for example, I have 1 over x minus 3 times x minus 2. And this is going to be over 3 x minus 2, and that's a and b, right? Right away, what I can do is I can say, okay, what would make this denominator 0? Well, x equals 3. I'm going to go to the original, I'm going to cover up the x equals minus 3, and I'm going to plug in x equals 3. So, to find the a, what I'm going to do is I'm going to go to the original. I'm going to cover this guy up and plug in evaluated at x equals 3. You'll notice that you'll get 1 as the answer. That's actually your a value. And that's always going to work. That will work all the time. Now to find the b value, you do the same thing. What would make that 0? X equals 2. You go over here, you cover up the x minus 2, and you plug in x equals 2. So for the b value, you go here, x minus 3, x minus 2. Well, the b is the numerator of x minus 2, so you're going to cover that up. And then evaluate that as x equals 2. That's going to give you 1 over 2 minus 3, which is minus 1. And hey, that's your b. b equals minus 1. Right? You can always do this, right? So if we had something like, so this is just like a side example, kind of going off on a tangent here. It's a nice trick to know. So if we had, okay, 4 over x minus 2 times x plus 1, what is the partial fractions? Well, if I put x minus 2, x plus 1, all I realize, x equals 2 is going to make this 0. Cover that up, plug in 2. What do I get? 4/3. That's going to be the answer. For x plus 1, x equals minus 1 is going to make that 0. Cover that up, plug in minus 1. What do I get? Minus 4/3. That's the partial fractions. It works for linear non-repeating factors. Meaning, if this were squared, it doesn't work anymore, right? Or if on the inside that were a square, it doesn't work anymore. But as long as it's linear, it looks like a straight line, and it's non-repeating, you can actually find the coefficient in this way. Right? And it's a consequence of a much larger theorem called the residue theorem. But it's a nice little trick you have for a Calc 2 partial fractions with linear factors. And if you go through either one of the methods I told you last time, you'll realize that the answer is going to be 4/3 for A and minus 4/3 for B respectively. It's a little trick you can have. Some people call it the cover-up method. Yeah.
Or does the cover-up method work if the top is only a constant, or can it
The
work?
cover-up method works in all cases where the denominator has linear non-repeating factors. So yes, it would still work if I had, say, 4x over x minus 2, x plus 1. I would still break this up into x minus 2, x plus 1. I don't care what the numerator looks like as long as it's proper. Cover this up, plug in 2, you would get 8 over 3. And cover this up, plug in minus 1, you would get minus 4 over minus, you get positive 4 over 3. And if you combine these two, you will actually get that. Called the cover-up method. So you do that with your friends from the other Calc 2 class. You just do it in like you're doing it in your head. Like, how'd you do that so fast? You gotta work hard, man. Work hard every day. I wake up early to study math. That's all I do. No, it's like a trick. But it's nice to know these tricks so you can show off on your friends and make them feel bad about how hard they're working. I have to work up early in the morning so I can. So the b, we have 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. Alright, so I want to find the partial fractions. Step 1. Is it proper? Yes. Highest power on the top is a 2, highest power on the bottom is a 3. So it's proper. So now I can jump into partial fractions. What do I need to do then? Yeah.
And what I did was I first factored out x from the denominator. And then from there I factored out x squared plus 2x plus 1, which is x plus 1 and x plus 1. Or x plus 1 squared.
Okay.
And then from there, I made it into x plus 1, and then a in the top, plus x plus 1 squared, and then b in the top, plus x, and now just be c. And
Right.
then,
So that's how you break it up. Right, based on what we were doing last time. And then,
just multiply out the denominator.
so if we multiply through by the denominator on the left, we would end up with 5x squared plus 20x plus 6 equals. Multiplying this by that, the x plus 1's cancel, you would have a times x plus 1. Multiply this by that, the x plus 1 squares cancel, you would just have bx. Multiply this by that, the x's cancel, you will just have c times x plus 1 squared. So now that's the equation that you're going to use to find the a, b, and c. How do we go about it? Yeah.
You could first make x equals 0.
X equals 0 seems like a nice thing to try. On this side, I would get a 6. On that side, this is going to wipe out the a, 0 is going to wipe out the b, and we're just left with c times 1. So I immediately get c equals 6. How do I find the other ones?
Plug in -1.
X equals minus 1, what is that going to give me? Well, here it's going to give me 5 minus 20 plus 6. On this side, it's going to wipe out the a, it's going to wipe out the c, and it's going to leave me with the b. Well, it's going to leave me with minus b. So now I have the equation with only minus b. And that's going to be what? Well, that's 11 minus 20. That gives us what? Minus 9. So our b is 9. How do you get the c?
You put,
You just plug in A and, or sorry, C and B.
Yeah, plug in c and b, and then essentially plug in any other value for x, right? So let's just plug in a nice value, something that's not going to get too big, say x equal positive 1. Now it's not going to eliminate anybody, but because I know the values of the c and b, I can plug these guys in, and if I also plug in the x values, a is going to be the only unknown left. So if I plug in, say, positive 1, on the left side I would get 5 plus 20 plus 6. Here I would get a times 2. Here I would get b. Here I would get 4c. But I know what b and c are. So b, that's a 9, and c is a 6, so this will give me 24. So in other words, I have 26 plus 5, that's 31, is going to give me 2a plus 9 plus 24. Or in other words, that's 2a plus 33. So my 2a is going to be equal to, subtract the 33, I'm going to get minus 2, which means my a is minus 1. And so this fraction over here, 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x is going to be a over x plus 1, which is minus 1 over x plus 1, plus b over x plus 1 squared, but my b is 9, plus 9 over x plus 1 squared, plus c over x, and my c is 6. And that's how I can think about it. Yeah.
You wouldn't be able to use the cover up, right? The cover up theorem?
No, because this is a repeated factor.
Okay.
So here, it's a repeated linear factor. Can't use cover up. You could in fact use it to figure out the x though. So if I were to say, okay, x equals 0 makes that 0, I can go over here, cover up the x and plug in zeros, and you'll realize that you do get 6 as the answer. So it'll work on the piece that fits with the conditions of the theorem. But no, if you try to do that with the square, it's not going to work out for you. So that's the partial fractions of those things. Okay. Now, of course, sometimes the algebra here can get a little bit annoying, but you do want to be relatively quick with the partial fractions part, because it's very rare that I'm only going to ask you to do a partial fractions. It will always be you have to do a partial fractions in order to do something else, like integrate. So if the question was to integrate this, you would first find the partial fractions and integrate that, because integrating these is way easier than integrating that. So partial fractions usually is going to be like the first step in a multi-step stage. So you're really going to want to get used to how things are working here. So 2x cubed minus 4x minus 8 over x squared minus x. Okay. Is that proper?
No.
Yes.
No, it's not.
Why not?
Because the bottom is 4 and the top is 3.
Oh wait, that is.
So
That is
it's
proper. The bottom is 4 and the top is 3.
Yeah.
Top is smaller, so that's it is proper. So the next thing you want to do is make sure the denominator is factored. Do we have that?
You can factor out.
You can factor it further. You need to be fully factored. So don't let the fact that it kind of looks factored fool you. Factor it all the way. Right? So technically that's what your starting point is going to be. And how do you want to break this up?
A over x plus b over x minus 1 plus cx plus d over x squared plus 1.
So that's going to be the first phase. So now we know how it needs to look. And what we need to do is find the a, b, c, and d. So what we're going to do, multiply both sides by this. For the a term, the x's are going to cancel. So I'm going to have a times the x minus 1, x squared plus 4. For the b, the x minus 1s are going to cancel. I'm going to have b times x squared plus 4. And for this one, the x squared plus 4s are going to cancel. So I'm going to have c cx plus d times x minus 1. Okay, what do you want to do now? Yeah?
I don't know, but you said that we could since the x term is considered proper, we could get you could use a cover-up term for that.
No, can't. For which term?
For x.
For the first
For
phase.
these and this?
Yeah.
Yes.
Yeah.
So that's what you want to do. So for a, cover up method. So what is that going to tell you that a is going to be equal to?
You plug in x equals
2.
0.
Plug in x equals 0, you get minus 8 over, of course you cover up the x while you're doing this,
Yeah.
over minus 1 times 4. Right? So right away that's what? 2.
Then you can do it for b over x minus 1.
You could also do it for the x minus 1. So for b, let's do the cover up. So the b is going to be equal to, I'm going to cover up x minus 1 and I'm going to plug in the thing that would have made that 0. So that's going to give me 2 minus 4 minus 8 over 1 times 5. Right? So that's minus 10 over 5 minus 2. So we can find the a and b quickly. What about the c and the d? How do we get those guys?
Plug in.
Just plug it back in. Oh, wait, never mind.
So the cover-up method is not going to work to help us with this, so we have to go back to our first principles. We have two methods from last time. Which one do you want to try here?
The first one.
Okay? Can you find a convenient value here?
You can't plug in
Not
zero,
really.
alright?
If you plug in 0, you're going to kill the C and the
Yeah.
D. Also, if you plug in 1, you're going to kill the C and the D.
And then there's nothing you can really plug into x squared plus 4 to get
There's nothing else. But technically what you can do is just plug in anything and actually plug in the values of A and B and see where you are. So let's say you plug in anything else, like something small, like say x equals minus 1. What would be the result here? So then that would be minus 2 plus 4 minus 8. This will be A times minus 2 times 5. This will be B times minus 1 times 5. Plus this will be minus C plus D minus 1 minus 2. Let's clean this up a little bit. So on that side we have minus 6. And on this side, I know my A is 2. So that's going to be 4 times 5, that's minus 20. I know my B is minus 2. So that's going to be 10. Then I'm going to have, this is going to be 3, so it's minus 3C plus 3D. Cleaning that up a little bit more. I can get, so this is minus 10, move it over there, that's going to be plus 10, so that's going to give me a 4, is equal to minus 3C plus 3D. Right? So we end up with this equation, which has two unknowns, can't really finish that up. So what I'm going to do is get another equation like that by plugging in some other value.
Where did you get the 3 from?
Shouldn't it be a 2?
Where?
2C, 2D. Yeah.
I think you just added instead.
Oh, I added, yeah. So that's a 2. That's a 2. Which means this is a 2. That's a 2. So this actually works out into something a little nicer. I can divide both sides by 2. 2 is equal to minus C plus D. Let's use that. That's nice. And now I'll plug in something else. I already plugged in 0 plus or minus 1.
Plug in 2.
So if you plug in 2, something very small that's not going to make things too big. I mean, technically anything you plug in is going to work. You could plug in x equals 1,000, but why would you do that? So let's say x equals 2, and what's that going to result? So the first term is going to be 8 times 2, that's 16. The second term is minus 8 minus 8, so that's actually 0 on this side. And if I plug in 2 over here, that's going to give me A times 8 plus B times 2 times 8 plus 2C plus D times 2. And I actually know what the A is. A was 2, or B was minus 2. So I can plug that in. So this means that 0 is equal to 16. And that is 16 times minus 2 plus 4C plus 2D. So that's going to be 16 is equal to 4C plus 2D, or in other words, I can say 8 is equal to 2C plus D. So that's another equation. So call that equation 1, and then equation 2 is going to be the 2 is equal to minus C plus D. It's equation 2. Or I can do, like, subtract. Let's say I take 2 minus 1. This minus that, I would get minus 6. This minus that, I would get minus 3. This minus that, that goes away. So my C is equal to 2. Then I can just plug into this one. This means that 2 is equal to minus 2 plus D. This means that your D is equal to 4. So that means our 2x cubed minus 4x minus 8 over x squared times x squared plus 4, that's going to be equal to a over x plus b over 1 x minus 1, so that's minus 2 over x minus 1, plus cx, c is 2, plus 2x, d is 4, plus 4 over x squared plus 4. Questions? Are we cool? Okay, 3 minutes, do it. Let me know what you get. Anyone finish or? It's a long one. Okay, how do we start this? Yeah.
It's already in proper form, so if you do, x squared equals 2, the top is a plus b, plus x squared plus 2 squared, all squared, and then cx plus d.
So that's 4 constants here, so probably will break down into a system of 4 equations, 4 unknowns, so
And
hopefully at least everyone have 4 equations, 4 unknowns, so it's okay. So now, what does this become?
I multiply the whole denominator becomes x. 8x 2/3 plus 13x equals x squared plus 2 times ax plus b plus cx plus d.
Right?
And then what I did was I made x equals 0.
So we had 0 here, and we would get what?
0 equals 2b plus d. So then that means d equals negative 2b.
Can file that away. Once I know what b is, I will automatically know what d is.
And then I chose another value, like x equals 1. That's the same exact one I chose.
Yeah.
And then I got 20. Wait, no, sorry.
That'll be 21.
21 is equal to.
It's all messed up.
No, it's fine. I was in that part.
Yeah.
No.
Okay, so 21 would be equal to
A plus 2a plus b plus 2b plus c plus d.
a plus b times 2 plus
C
c
plus
plus
d.
d. That's
And then-
2a plus 2b plus c plus d. Right? Then what would you do?
I switched the d to minus 2b.
Okay, so 21 equals 2a plus 2b plus c, but d is minus 2b.
And then from there I got
So the 2a plus c equals 21.
yeah.
What else would we do here?
I got
That's
3a.
Yeah.
Huh?
I got 3a.
Because wouldn't it be
Yeah, I
a
think
plus
3
b
here.
times 3?
yeah.
3, 3.
Probably said something. I don't want to.
You're gonna do the wrong thing?
Yeah.
Didn't want to interrupt you.
Sorry.
Just what happens. Yeah, no, you shouldn't mix those. It's kind of explosive, but didn't want to interrupt you. What else do we have?
That's all I have.
Plug in another one. Say minus 1. What's gonna happen here? Minus 21 equals minus a plus b times 3 plus minus c plus d. So this is going to be minus 21 equals minus 3a plus 3b minus c plus d. And you could again replace D with minus 2b here. Right, and so that would be minus 3a plus b plus c minus c. We'll need one more equation. So say x equals 2. What is that going to be? 64 plus 26 equals 2a plus b times, that'll be 4 plus 2 and 2c plus 2. So
Wait, where'd you get the 6 from?
we're plugging in x equals 2.
So it's in 4, okay.
That's 4 plus 2, that's 6. Right, and that's 2d plus and then that. And then 64 plus 26, that is 90. Equals 12a plus 6b plus 2c minus 2b. So we have 90 is equal to 12a plus 4b plus 2c. In fact, I can divide both sides by 2 here, get that a little nicer. 45 is equal to 6a plus 2b plus c. Now we have 3 equations and 3 unknowns. We have this one, we have this equals minus 21, and we have this one. Now I can solve that for a, b, and c, and once I know what b is, I can automatically find d. So this is going to be, let me copy them over here. So 3a plus b plus c equals 21.
It's negative 3a.
Where? Yeah, it's negative.
Where?
It's negative 3a plus.
For this one?
Oh, yeah, never mind.
Yeah, I'm writing this one, and then this one is negative 3a plus b minus c equals minus 21, and then the last one is 6a plus 2b plus c equals 45. Okay, how do we go about this one? Well, I can add these 2 equations, right?
And you get
And I would get what?
2b is
2b is
zero.
equal to 0.
0.
Which is kind of weird because then b and d are 0.
B is 0, D is 0.
Wait, how'd you get d with 0?
Huh?
Oh, never mind. Never mind.
Because, yeah, because my
Yeah, 'cause
D
that
is
one,
minus
yeah.
2B.
So then you could just choose one equation and solve this.
Choose
You
one.
need to still solve for a, right?
Yeah, I need to solve for one of
You
these.
can
So,
subtract the
so now all of these guys, I can essentially just ignore all of these guys.
and you can subtract the never mind.
And let's say I
Fine.
added these 2,
Yeah.
for example. Add those, I would get 3A, the C would go away. 45 minus 21 is what?
24. So a is 8,
A is 8.
and then
Now
c
you
is
just
negative 3.
Plug in.
And so now you have negative, just plug in here like negative 24 minus C is equal to negative 21. So minus C is equal to
3.
3.
So c squared.
C is negative 3.
Negative 3.
And so at the end of the day, we have A is 8. 8x over x squared plus 2. And my C is negative 3 minus 3x over x squared plus 2 squared. It's going to be the answer to that.
Don't you have to, oh wait, no, b and d is 0, right?
B and D are 0. The next one should be pretty quick, but I want you to do the integrals like on your own and for next week. X squared over x squared minus 1. What do you do with that?
You could factor the bottom to x plus 1, x minus 1.
Forgetting the first.
I mean, no,
Huh?
So
It's not proper. So I forgot the first step. It's not proper. How do we do
a long division.
long division? Think of it an easier way?
divide. Minus 1 and plus 1.
-1 plus 1 in the top. How does that allow you to break this down?
1 plus 1 over x squared minus 1.
Get that? Now you want to do partial fractions on this
X
guy,
plus 1, x minus 1.
which now you know that's going to be x minus 1, x plus 1.
And
You usually cover up, so you
You
have
just cover up what is over here.
1/2. And then -1/2.
Yeah. Anyway, so try those integrals on the problem 2. Be sure to actually try them. And we'll stop there. We'll pick up with that stuff next week.
I need to feel that.
You can also see it on the video.
Thank you.
Right?